What's going on, you guys? Mr. Allen here. We're about to do some non-right triangle trig. We want to solve for all missing sides and angles in triangle ABC. All we're given is angle B, side A, and side B. So let's first draw up a triangle. Now, it doesn't really matter how you label your vertices as far as like where you start A, B, and C. I'm going to start in the bottom right here for A this time. I'll tell you why later. Okay, so angle B is going to be 25 degrees. That's this one right here. And it does look to be pretty small. It's acute, so that kind of matches up. I like to make it look as best I can to what the triangle might look like. Across from that is going to be side B, which is going to be 19 feet. One tick mark means feet. And then across from A is going to be your 23 feet. So that's going to be this guy right here. I don't know side C, I don't know angle A, and I don't know angle C. So what am I going to do here? It's either law of sines or law of cosines. I always try to do law of sines first because it's the easier formula to work with. Do I have an angle and a side across from each other? Yes. So I'm able to set up law of sines with this one because I'll have a completed ratio in my super proportion. We're going to solve for angle A first since I know a side across from it. So let's set that up. I'm going to have the sine of angle A over its side of 23 feet equals the sine of angle B, which is 25 degrees, divided by its side across from it, which is 19. And now I can cross multiply and solve. So I'll have 19 times the sine of angle A equals 23 times the sine of 25, and then I'll divide by 19 on both sides. That's going to give me sine of A. I'm going to have this terrible decimal. So let's pull up our calculator. Now, the first thing that I do when I pull up my calculator here is make sure that I'm in the correct mode. We're dealing with degrees here. As you can see, I am not. So I'm going to arrow down twice, over once, hit enter. Even if I put it in degree mode, if my batteries come out or if I have to, like, if it dies and I have to recharge it, it'll default back to radian mode. So you do want to check that, especially if you're getting like weird answers that don't make any sense. All right, so now what I'm going to do is I'm going to type in 23. So 23 times, and then it's going to be the sine of 25. So sine 25 degrees. I'm going to close my parentheses, and I can either just divide by 19 right here, or I could hit enter and I'll hit divide by 19. Either way is fine. Order of operations, will do the multiplication first, and then the division second. They go in the order in which they appear in the problem. All right, so now I have this decimal equals sine of A. And if I want to get sine, or if I want to just get angle A by itself, I have to do inverse sine on both sides. The way that looks is we've got sine of angle A equals this 0.511 and change. Well, I want to get just angle A by itself, so I have to take what's called the sine inverse on both sides. Whatever I do to one side, I have to do to the other. That's going to cancel out my sine and leave me with just angle A equals something. So back in my calculator here, I can just go ahead and hit second. As you can see up there, it says like sine -1. Hit that, boom, I get sine inverse. And then what I want is that number that's right above. Either you can hit second, then the negative sign, which is ANS, and it'll put that in there, or my preferred method, if your calculator does that, is I arrow up, I hit enter, I close my parentheses. That's not necessary, but I always do just out of good habit. And then I hit enter. I get 30.7698 degrees. So I'm going to write down the first three decimal places, 30.769, so 30.769 and change. And then in my triangle, I'll go ahead and put the rounded value. So that's going to be 30.77 degrees. Okay, cool. So we've got that. Now, with law of sines, if we have an angle side situation, we know an angle here, a side, and a side. The angle is not between the two sides, so it's not a side angle side, it's an angle, then a side, and a side. There's the potential for a second triangle to exist. There's also the potential for no triangle to exist. That's in a different video. But there's the potential for a second triangle to exist. So I either need to check for that now or finish solving this triangle and check later on. But you don't want to forget, I personally like to check right away, and then I know if I'm dealing with one or two triangles. So let's check for that second triangle right now. So to check for the second triangle, basically what we're doing is we're seeing if this particular side right here could swing in over into this area right here to create this second triangle without changing that 19-foot length, the 23-foot side, or that 25-degree given angle. Obviously, this is going to be a totally different triangle, but it's possible for that to occur where it swings in, okay? So let's think about how the heck that could even happen. Well, if that side's going to be 19 feet, just like the other one, this is an isosceles triangle that we have going on within this whole context of the problem. Well, that means that this angle right here is also going to be that 769 and change, right? So what's the other triangle's angle that could occur right over here? Well, that's going to be the supplement of it. And then we basically have this whole other triangle, this guy right here in green, all the colors right now. That triangle could exist with that other angle. So we got to figure out what that other angle might be. I know there's a lot of mights here, and that seems crazy, right? Okay, so what I'm going to do is I'm going to find the supplement of that 30.7. So 180 minus that 30.769 and change. So I'll do that in my calculator since I've already got these numbers up, right? So 180 minus, and then I'm going to arrow up, and I'm going to hit that enter on there. It's going to copy it down for me. So 149.23 and change. That's my other potential angle for this triangle, right? That's the other thing that could possibly happen here. But we need to see if that even works. I know, right? We're not even done seeing if we have a second triangle. I need to see if that works. Well, the other given angle in this triangle is 25 degrees, right? That's the other one. So I need to see if that angle plus the one that we just found out that's a potential will add up to less than 180 degrees. Why am I choosing that? Well, there's 180 degrees in the triangle. So I want to see, hey, is there another triangle that can exist with these two angles going on here? 174.23? Yes, there is another triangle that can exist because those two angles add to less than 180 degrees. So let's show that work. So now we have this second triangle that we're going to work with. Now what I'm going to do is I'm going to trace this best I can, okay? That is kind of awful, but, you know, we'll roll with it. And then I'm going to go ahead and bring this guy over here, okay? And that is going to be my second triangle that I'll work with here in a little bit. Now, what I'm going to do is I'm going to label that with my given, which was 25 degrees. We had the 23 feet. We had the 19 feet. This was B right here. This was A right here. And up here is my vertex C. Now, the information we found was that this is going to be 149.23 degrees, and then I can get my other angle from there. So we're working with two separate triangles. What I'm going to say is let's finish the first one up here, and then we'll go to this second triangle. So I'm going to clean up my triangle right now with all this yellow marks and stuff like that so we can then finish this one out. So what else do we have to do in this blue triangle here? Well, I've got a 25 degree angle and a 30.77 degree angle. I could probably find out angle C here with some pretty easy math, right? We got 180 degrees in a triangle. So what I'm going to do is I'm going to take that 25 degrees, so 25 plus, and then the other angle I had was the 30.769. I'm going to arrow up. I'm going to grab that guy, right? Boom, right up there. Hit enter. So I can add those two together. And if I take 180 minus that, 180 minus the 55.769, then that will give me my third angle of this blue triangle, which is 124.23 degrees. So 124.23, we're doing these in pink, 124.23. Woo! All right, there we go. There's my other angle of this triangle. Last thing I need to figure out is my side length, right? So I'm going to set up law of sines again. I'm going to use this guy here that was given to me. Okay, I'm going to use that guy that was given to me, and then I'll use the new angle C that I just got along with the little side C. So let's set that up. So we've got sine of 25 over 19 equals, and then I've got sine of 124.23 and change over, and then I have side C. So now I can cross multiply and solve. Let's do that all in our calculator since we're running out of room here. So I'm going to have 19, and then it's going to be times, let's see here, times the sine of that terrible angle right up there. So I'm just going to copy it in. Don't need to type it all in, right? And then I'm going to be dividing by the sine of 25, right? So divide by sine of 25. And this one doesn't have any kind of like an inverse issue or you know, that we have to do because I'm just finding my side length. So at this point, I would isolate C algebraically, and I'll get 37.170. So C equals 37.170 and change, which means that this is 37.17 feet. I've got that answer, I've got this answer, and that one. All three have been accounted for in this first version of the triangle. Now I got to go on to my second triangle. Oh my goodness. Let's go ahead and scooch this stuff over here. I'm going to draw this yellow triangle a little bit larger. All right, so we're working with the second triangle now. It kind of finishes out the same way. We're just using some different numbers here. I've got 25 degrees for an angle. I got 149.23. I think we already actually have that other, well, no, we're close to having that other angle. We did add those two together. We got to find angle C, right? So I would have 180 minus And then if I arrow up, we already added together the 25 and the 149 when we were doing our second triangle check, right? It's that 174 right there. Let me just show you the work. Boom, there we have the 149.23 plus 25. That's 174. So I'm just going to use that right here. Hit enter. It copies it down, and I've got 5.769. So angle C, 5.769. And change. So we'll put 5.77 degrees. Boom, there we go. Awesome. Perfect. So I've got my angles. Now I just got to get my side C, right? Well, we're going to use the same kind of setup we did for the other one. I'm going to have the sine of 25 degrees over 19 equals, but this time I'm using 5.769 for my angle. So sine of 5.769 and change divided by what I don't know for side C right there. So let's plug it all into our calculator just like we did before. I'm going to have 19 times the sine of, and I'm going to use that angle right up there, right? Unrounded values, folks. Unrounded values. And then, well, in the calculator. All right, and I'm going to divide by the sine of 25. So sine 25, boom diggity. Hit enter. We get 4.519. That seems really small, but think about this. That's the smallest angle. It's only 5 degrees there. It should be my smallest side, right? Across from my angle should be my largest angle should be my largest side. Across from my smallest angle should be my smallest side. So that makes sense. 4.519 or 4.52. This is my last one, so 4.52 will do just fine. Boom. Answer, answer, answer. Woo! We just solved 2 triangles. That was absolutely crazy. And we did it all by following the laws of yo-ro, right? Yo-ro. You only round once for mathematical accuracy, right? We didn't round twice. We didn't yort. We didn't yort 3 times, right? We didn't yorf. That would have been crazy and just reckless and irresponsible, honestly. All right, so keep those numbers in your calculator. Use your arrows or store them if you can't use your arrows. And I hope you guys have a wonderful day and enjoy this video. I'll see you later. America, freedom, rock and roll, Costco, Riverdog, Jenny on the gram. And of course, I don't know what else. See you later.